Hello everyone. In this lecture, we are going to see the way of printing matrices and the various matrix operations we can perform. Still now we have seen a basic variables printing. Now we are going to see similarly how we can print an single dimensional array, two dimensional array, nothing but matrix. Now you can see here I am giving multiple values as we know list in Python. See, you can see here we got in this format. Yeah, now coming to two dimensional. Let me explain 1 comma 2 semicolon 3 comma 4. It will print 2 by 2 matrix. In first row, the numbers will be 1 comma 2 like this. Those numbers will be printed. This semicolon, as we know, end of line. So the 3 comma 4 will be printed exactly below 1 comma 2. Yeah. Now you may get the out that what if we enter one more parameter, that also I am going to demonstrate. 1 comma 2 semicolon 3 comma 4 comma 5. Yeah, inconsistent row or column dimensions. Here how many values you are giving means that is nothing but before the separator semicolon, all the individual count should be same. Here there are only two values but here three values. So there is a mismatch. You can see this is a square matrix. Now, similarly, we can print rectangular matrix too. E equal to 1 comma 2 comma 3 semicolon 4 comma 5 comma 6. Yeah, this will print 2 by 3 matrix. Yeah, 2 rows, 3 columns. This is the way of printing rectangular matrix. Now coming to addition of two matrices. Now let me clear the console once. Yeah. Now let us consider two individual matrices. Capital A equal to 1 comma 2 comma 3 semicolon 4 comma 5 comma 6 semicolon 7 comma 8 comma 9. This is matrix A. Matrix B in reverse I will give 9 comma 8 comma 7 semicolon 6 comma 5 comma 4 semicolon 3 comma 2 comma 1. This is matrix B. Similarly, we can perform matrix additions as we perform the addition of two variables. Yeah, here you can see any two values sum is 10. So entire matrix is also 10 itself. Now how to print transpose of a matrix? For this A plus B I am not doing because all values are same, so you may confuse. So this is the actual matrix B. We know that transpose is nothing but we will convert rows to columns and columns to rows. B dash. Yeah, this complement symbol indicates the to transpose the matrix. Let yeah, B transpose. Now you can see the columns becomes rows and rows becomes columns. Yeah. Now similarly, now I am going to store the transpose in another matrix. Let me call it as X. Now I am going to, yeah, you can see there itself, since I have not given semicolon, directly we got it. And also we can calculate the size of the matrix. Yeah, matrix size, how can we calculate? Since it is two dimensional, it consists of two values, row comma column. To get the size, there is a inbuilt function size. Size of any matrix you can give. X matrix I am taking because all are same. Yeah, you can see that column value is 3 and row value is 3. Now, since here it is 3 by 3, you may confuse whether it is giving correct answer or wrong answer. So now I am going to make use of it by taking another matrix. Let me take A equal to 1 comma 2 comma 3 semicolon 4 comma 5 comma 6. Yeah, here you can see 1, 2, 3, 4, 5, 6. It came correct. 2 rows, 3 columns. Now I am going to perform similarly for this one. Instead of X, I am going to give A. Yeah, here you are getting correct values. See, row is there are two rows, column is nothing but see, I have indicated three columns. This is how you will get the size of a matrix. And to get some particular element, let me say I want to print one of the elements. I can call directly by using matrix within the parenthesis 2 comma 3. Yeah, here you can see it will get 6 because I am calling second row, third column. Here you don't confuse it as it is similar to matrices. Index, there is no index that is starting from 0. Not only here, in case of images also, the matrix index values begins always with 1. This matrix we are saying 3 by 3 because three rows and three columns start with 1, 2, 3 as numbering, not as starting with 0. That's the reason you got output as 6. Now I want to print the elements of some particular row only. Let me take A of, yeah, we know that here you can see first parameter is row and second parameter is column. So first let me take all the elements of a row. In we can select any one column. Let me take it as column 2. Yeah, here you can see 2 comma 5 you have got. This colon indicates that all the row element you want that are present in column 2. That is nothing but 2 and 5 you will get. Similarly, now to get vice versa, if you want to print the a particular row elements, let me take first row elements. Yeah, in middle comma we need to keep. Now you will get all the first row elements. This is how matrix operations we perform in Scilab. And next, in previous lecture, I forgot to inform another inbuilt function that is factorial of a number. Yeah, for factorial, there is a directly predefined keyword that is factorial itself. You can use factorial of 5. See, you got answer as 120. Factorial is an inbuilt one. Thank you. And in the next lecture, we are going to see about plotting.